This is the video for the magnetic fields lab. So what you're going to do in this lab is you're going to make a coil, and you're going to measure the magnetic field that's passing through the center of that coil. So to make your coil, you're going to, what you can do a number of things, but what I'm going to do is I'm going to take the iLab device and the multimeter and put them together, and then I'm going to take my wire and just wrap it around with the vise. And so you don't want to do it too tight, or else you might have a hard time taking it off the two devices. Alright, and you can wrap this around as many times as you want. Alright, and then you can either cut, or you can simply break it with your hands because it's very thin wire. I'll just slip these off and try to keep the coil from undoing itself. And you're going to try to straighten it out, make it into a nice circle, and you're going to want to leave some leads on the end, so just a few inches that you can work with. Alright, and you're going to want to make sure you count how many coils or how many turns you made in your coil. You can use some electrical tape or other tape if you want to hold the coil together. Let's take a little bit off here. And this will just keep the coil from unraveling. I'll just do a second one. Alright, now I have a nice little coil with a few turns. It's not going to unravel on me. So this is magnet wire. And what magnet wire is basically it's a copper wire, and it's got a thin enamel painted on it. So yours should be red like this, unless I gave you one that's a green wire. Then it's a green painted enamel on it. And you'll take your sandpaper and you'll just want to take maybe about an inch of the enamel off. So I'm just kind of squeezing it a little bit, and you want to not do it too roughly, or you can actually break the wire. So you want to make sure you do it real good to get all that red paint off. Alright, then you'll be able to see it's a nice copper color, so you'll definitely be able to see the difference there. And you want to make sure it's all off on both ends so that you can make a good connection. If you don't have a good connection, then the electricity won't flow and you won't be able to measure anything. Alright, now you're going to hook everything up. So first thing is your 2 AA battery pack. Alright, so you have a 9-volt battery pack and one that has 2 AA's. So just open it up, make sure you're using the right one, and it's got a little on-off switch there. And then you'll just connect the 2 leads like this. Okay, so on the side of the breadboard you have a red positive and a blue negative, and basically everything underneath that blue negative sign, they're all connected, and everything underneath that positive red sign, they're all connected. So we're going to insert the positive lead into the positive, and the black is the negative. We'll insert that into the negative. Alright, and then I'm going to take my coil, and I want to make sure that the center of the coil is right on top of the magnetometer. So the magnetometer is this M right here. It's actually just a little bit below it. Alright, and that's going to be what the sensor that measures your magnetic field strength. So make sure that you calibrated your magnetic fields sensor, the magnetometer, before you do this lab, so you can get some accurate results. Alright, make sure you do it away from anything that's metal. I know on my desk the frame is got a metal frame to it, and so that was interfering with me getting correct data, so I had to kind of put it somewhere else in order to do that. Alright, so I'm going to take my coil, I'm going to put it on the iLab device. I'll take a piece of tape so I can kind of tape it in place once I find a good center. Okay, so it's centered pretty good, and you want to make sure it's nice and flat on here. Alright, it's okay if this end is a little bit tilted down. might even give you better data because the magnetic field sensor is actually below the surface a couple millimeters. And we're going to take one end of the coil and we're going to plug it into the positive of the breadboard. Okay, and if it's too loose, you're not going to get a good connection, so you could always fold this end of the coil in half, kind of like that, and then slip it in that way. That way it'll go in a little bit tighter and you'll have a good connection. Alright, so that's where you have the one end of the coil plugged in. And then I'll take my multimeter here, and there's a 20 or a 10 amp setting, this one here, so I'll turn that all the way to 10. And then we're going to plug, so you have two of these cables here. These are banana plug cables, and you should have a couple of alligator clips too. And it doesn't matter which color you use, but I'm going to use for my black, I'm going to put it in this bottom one that says COM. And then I'm going to take the end, so if the alligator clip's not on it, it should be in your kit somewhere, just find that. And then I'm going to attach it to one of these jumper wires. Again, it doesn't matter which one, what color you use. So I'm just attaching it to the end, and then I'll plug this into the negative end of the breadboard. Okay, and then the last thing you're going to do is you're going to take your other banana plug cable, and on one end you'll have the alligator clip, and then you'll plug that into the multimeter on the top one where it says the 10 amp, so it's going to be that top one, so you have the one in the middle will be empty. And then we'll attach this alligator clip to the other end of the coil and make sure it's on nice and good and it's touching the copper part so we have connection. Alright, so that's your setup. So then you're going to go on to your software, and I've already got it opened up so you can see I'm paired here. So I just need to turn the device on, and we'll go to connected, and then I'll go down the sensor list here and click on magnetometer, and it'll come up with 3 different B's. So B represents your magnetic field, so the X, the BX, and the BY we don't really care about, it's the BZ we care about. So when you look on your iLab device, you'll see that there's X, Y, and Z coordinates made, so the Z is actually going down and up. So when we have the iLab device sitting like this on a table, right, Z is kind of going down into the earth and up out of the earth. So that's the portion of the magnetic field of the earth that we're going to want to subtract out, since we have the coil placed basically so the center is going through the Z axis. Alright, and so I'll press record my magnetometer sensor, so you can see I'm just a little bit under 50. Okay, so if it's the closer you are to 50, the closer your calibration is. Alright, and then I'll turn the battery pack on, and you'll notice how it just kind of jumped down there, so I can't even see it because it's so far under. Alright, and then I'm looking at my multimeter. I see I got 3 amps going through here. Alright, and if I touch the coil, I can feel it's getting hot, so I'm going to turn that off now that I got some data. And I'll press stop on my magnetometer sensor. And then when you use this data tool here, those bars, you can go over here and you can see the parts, so I can grab over here, grab and drag, and you see the mu up here is telling me the average. So that's the average magnetic field of the Earth. According to this is about 37, so I'm a little bit off there, but that's not too bad. And also notice that it's saying negative. Okay, so when I go over here to this part, I can click and drag across that and get an average. Alright, so there's my average magnetic field while the battery pack is on and running through the coil. Alright, so I could subtract that, the magnetic field of the Earth, that 37 that I had before, 37 microteslas. I could subtract that from the 267. Alright, so be careful here. So if you have the coil going the other way, if you had it flipped over, then you might be getting a positive magnetic field. So you just got to be careful with your sign so you're subtracting accurately, so you're getting the magnetic field just of the coil and not the Earth. Okay, so you've got your measurement of your magnetic field strength. You got your current measurement from on here. So from everything you've taken, you can now measure the radius of your coil, and you will be able to calculate mu naught, the permeability of free space, or what we call the magnetic constant. All right, and then the final step, you will kind of reverse engineer what you did here to determine how many number of turns there are in the coil that I provided for you. All right, so there's a big coil similar to this that it's wrapped up with some electrical tape. All right, so just be safe with this. Make sure you turn the battery pack off. Try to keep the battery pack on for no longer than a minute, so as little time as possible, and you'll be safe, and then not get burned or cause anything to short out there. And that's it for the Magnetic Fields Lab.